Alright, and welcome back. In this video, we are going to be going through Chapter 9, Section 7, titled Circles and Lengths of Segments. By the end of this video, we should be able to solve problems involving lengths of chords, secant segments, and tangent segments. So please have out your guided notes. Let's begin. So segment PQ and segment RS are defined as chords. Segment PX and XQ are segments of chord PQ. Segment Rx and segment XS are segments of chord RS. And the following theorem says that the product of PX times XQ is equal to RX times XS. Try saying that 5 times fast. It ain't fun. When two chords intersect inside a circle, the product of the segments of one chord is equal to the product of the segments of another chord, which again says that the length of PX times the length of XQ is equal to the length of RX times the length of XS, which leads to example number 1. In part A, if the length of AP is equal to 4, and the length of PB is equal to 6, and the length of CP is equal to 8, we want to find the length of PD. So what we're going to do is we're going to set up our products. AP times PB is equal to CP times PD. We can substitute in the values that we know. 4 times 6 is equal to 8 times PD. Or if you wanted to label that as X, that works as well. You want to create your own variables, just make it easier for you. I'm fine with that. So we solve and we end up with 3. So the length of PD is going to be equal to 3. For part B, if the length of AP is equal to 4, the length of PB is equal to 9, and the length of CD is equal to 15, we want to find the length of CP. We're going to say, hey, let CP be equal to X here, and then PD is going to be equal to 15, take away X. We can now set up our products. AP times PB is equal to CP times PD. Substitute in everything. We're going to figure out that 36 is equal to 15x minus x squared. We could then set that equal to 0 by bringing over that 15x and negative x squared, and now it becomes positive x squared minus 15x is equal to 36. We can factor that. We end up with x minus 12 times x minus 3 is equal to 0. Using the 0 product property, we're going to x is equal to 12 or x is equal to 3. So that means that the length of CP is equal to 12 or the length of CP is equal to 3, and both of those will work. With this in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to move forward. So now we have segment DF and segment HF. They are secant segments. Segment EF and segment GF are external segments of those secants, because EF and GF are on the outside of our circle. The following theorem says that the product of DF times EF, our entire secant, and an external segment is equal to HF times GF, our entire secant times the external segment. So here we go. When two secant segments are drawn to a circle from an external point, the product of one secant segment and its external segment equals the product of the other secant segment and its external segment, which leads us into example number 2. So in part A, if the length of PQ is equal to 9, the length of QR is equal to 3, and the length of TR is equal to 4, we want to find the length of SR. Well, we have our diagram, and we notice that point R is lying outside of our circle. So PR times QR, our entire secant, times the external piece of our secant, is equal to SR times TR. Again, our entire secant times part, or the external part of our secant. We substitute in our values and we end up with 9 is equaling SR. Now for part B, if PQ is equal to 11 and SR is equal to 12 and TR is equal to 5, we now need to find the length of PR. So we can let PR be X, then QR is going to be equal to X minus 11. So PR times QR, again, is equal to SR times TR. We substitute in our values. We end up with x squared minus 11x minus 60 is equal to 0 when we get everything to one side. And if possible, we want to have our A value be positive because it's going to be easier for us to either factor or then to solve. When we do factor, we end up with x minus 15 times x plus 4 is equal to 0, which then means that x is equal to 15 or x is equal to negative 4. And we know that we cannot have a negative length. So we can rule that out. So PR has to be equal to 15. With this in mind, please work on problems 5 through 8 on the guided notes and resume when you're ready to move forward. Alright, and lastly, segment PA is a tangent segment. Segment PC is a secant segment. So the following theorem says that the product of PC times PB is equal to PA squared, or, informally, the whole segment times the external segment is going to be equal to our tangent squared, which leads into this theorem. When a secant segment and a tangent segment are drawn to a circle from an external point, the product of the secant segment and its external segment is equal to the square of the tangent segment. And in example number 3, we see two pieces of that. So for part A, if the length of RT is equal to 25, the length of RS is equal to 5, we want to find the length of QR. We can note that QR is going to be our tangent, RT is going to be our secant, and SR is going to be the external part of our secant. So RT times RS is going to be equal to QR squared. We can substitute in our values. 25 times 5 is equal to QR squared. Thus, we're going to end up with 5 root 5 is going to be the length of QR. And in part B, if QR is equal to 6 and the length of ST is equal to 9, we want to find the length of RS. Well, if we let RS equal X, then RT is going to be equal to X plus 9, because we know that ST is 9. So RS plus ST would then give us RT. We can use our same equation as before. RT times RS is going to be equal to our tangent QR squared. We can substitute in everything, end up with x plus 9 times x is going to be equal to 6 squared. When we get everything and collect all of our terms on one side and set our equation equal to 0, we get x squared plus 9x minus 36. We can factor that. We get x plus 12 times x minus 3 is going to be equal to 0. Likewise, we're going to have x is equal to negative 12, or x is equal to 3. So when we substitute it in to our x plus 9, we have to get a positive distance. And x having a value of negative 12 does not allow us to have that positive distance. That turns into a negative distance. So the only value that we can include here, RS, has to be equal to 3. With this in mind, please work on problems 9 through 12 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.